All right, Math 2, Unit 6, Similarity Ratios for Area and Volume. So what we're going to be looking at here is we're going to be looking to see if we can find any special relationships between the similarity ratios of the two shapes, whenever you concern like the side to the side versus area to area versus volume to volume. So for starters, the directions say determine if the figures are similar. If they are similar, find the similarity ratio, and if not, explain why. So 1A, it says, are the rectangles similar? So because they're rectangles, we know that they have all right angles here, which means normally I'd check angles and sides. My angles I'm good on. Now my sides I need to check. I'm going to say, well, 10 over 15, does that equal 16 over 24? Well, 10 over 15 is, what is that going to be? 2 over 5? 2 over 3. And 16 over 24 is also going to be 2 over 3. So those are equal, so sides are good, and we say, yes, they are similar. The similarity ratio we can give as 2 over 3 or 2 to 3, like that. Part C says, what is the area of the smaller rectangle? Well, that's going to be 16 times 10, which is 160. And that's units squared, but we don't really care about writing that. And the area of the larger rectangle is going to be 24 times 15, which is 24 times 15, 360. So we scroll down more. It says, write the ratio of the area of the smaller to the larger. So we're looking at just the areas. So that's going to be 160 over 360, which that will reduce. Let's see what that can reduce to. 160 over 360. That's the same thing as 4 over 9. And we could, or 4 to 9. All right. So all of the things that I've written down so far should be things that we already knew about. We already know how to find if things are similar. We already know how to find similarity ratios. We know how to find area. And we can find the ratio of the areas by just looking at our area. Part F, though, says compare the similarity ratio and the area ratio. So let's just write those down. The similarity ratio is 2 to 3. I'll just write it as a fraction. 2 over 3. And the area ratio is 4 over 9. So it says compare them. And then what can be said about the similarity ratio and the area ratio? Well, 4 over 9 is the same thing as 2 squared over 3 squared. Do we see that? So we could say the area ratio is the similarity ratio squared. Another way to think about this, and I think a way that helps me to remember it, is that the 2 over 3, the similarity ratio, you would measure that in like feet, plain old feet, because you're talking about just the side lengths. The area ratio would be measured in feet squared. That can kind of help me remember that the area ratio is always the similarity ratio squared. And I don't know if I said this already, but in order for any of these things to work, the figures have to be similar. Right? So let's go on the next page. A, I don't know. Are the rectangular prisms similar? Well, we're told that they're rectangular prisms, so we don't need to check the angles. but we do need to check the sides. We'll take the smallest sides first. We'll do 1 over 3. Is that equal to 2 over 6? Is that equal to 3 over 9? Well, 1/3 is 1/3 is 1/3. So yes, we're good. So we can say the rectangular prisms are similar. What is the similarity ratio? Well, to get the similarity ratio, we look back up here at our 1/3. So it's going to be 1 over 3 or 1 to 3. Part C wants the surface area of the smaller rectangular prism. The smaller rectangular prism, let me zoom out just a little bit. We've got 3 boxes, and I'm going to have 2 of each of them, right? Because there's a front and a back to all 3 sides. This one we're going to say is a 2 by 1. We'll say this is a 1 by 3. We'll say this is a 2 by 3. Right. I'm just finding the surface area of that guy. Well, this is going to be 2 times 1 times 2 plus 2 times 1 times 3 plus 2 times 2 times 3. So this is going to be 4, 6, is that 12? 12. So 22, right? Those can be a 10, yeah. So 22. Do we have units on this? Inches. Inches squared. Now the surface area of the larger prism. I'm just going to write my 3 boxes. And we know that there's 2 of each of those. We're going to have 6 by 3, 3 by 9, and what's the only combination I haven't done? 6 by 9? 6 by 9. So I've got 2 6 by 3s, 2 3 by 9s, 2 6 by 9s. I'm going to type these in. I'm actually going to put 2 and then big parentheses around the whole thing. 6 times 3 plus 3 times 9 plus 6 times 9. And I got 198. All right. So again, just like in last time, everything I've done so far should be very much review. We know how to find a similarity ratio. We know how to find surface area. Part E says write the ratio of the surface area of the smaller to the larger. Oops. All right, sorry about that. That's going to be 22 over 198. Let's see if we can reduce 22 over 198. I think we can. Is it going to be like 1 over 9? 22 over 198. That is 1 over 9, or 1 to 9. Part F says compare the similarity ratio and the surface area ratio. Well, similarity ratio is 1 to 3, so we have 1 to 3 and 1 to 9. Well, again, just like before, we should be looking at this and we say, well, this is 1 over 3 squared. Right? This guy is measured in inches. This guy is measured in inches squared. So again, we can say, well, the surface area ratio is the square of the similarity ratio. Right? Just like before. So on that first page, on question number 1, right? Because there's just one question per page. Question number 1, we talked about the area. Question number 2, we talked about the surface area. So surface area and area follow the same rule. Any kind of area ratio is the square of a regular similarity ratio. Now let's look at the third one here. So here we have two rectangular pyramids, or I guess they're square pyramids also. And we want to know, are they similar? Well, we have the base of them has 5 to 10. The height is 6 to 12. And the slant height is 6.5 to 13. All of these are 1/2. Right? So we're going to say yes, they are similar. Right? I think I already said this, but a contingent to all of these rules is that they have to be similar. Right? So the similarity ratio would say, well, this is 1 to 2. The volume of the smaller rectangular pyramid, well, we need to remember what volume is. The volume is 1/3 big base times height. That's going to be, well, my big base, smaller one is going to be 25, right? 5 times 5. My height is going to be 6. So I'm going to say, well, my volume is 1/3 25 times 6, which is going to be 50. And it is feet cubed. Right? So right after I wrote that feet cubed, you might be able to think about what are we going to say for part F of this problem. All right, let's do the volume of the bigger one. So again, volume is 1/3 big base times height. Big base on the big triangle, or the big, what is it called, a pyramid. The big pyramid is 100 times 100, which is going to be, or 10 times 10, which is 100. My height is 12. So I'm going to say, well, volume is 1/3 100 times 12, which is 400. Right, it is 400, right? 12 and 3 give me 4. So yeah, 400. It tells us to write the volume ratio. Well, that's going to be 50 over 400, which is the same thing as 1/8. And I guess I've written it like this. I could say or 1/8. Now we're supposed to compare the similarity ratios. Well, we've got that 1 to 2 and the 1 to 8. So we've got 1/2 and 1/8. Well, again, we're going to be wanting to try to make the 1/8 out of the 1/2. Well, that is 1/2 cubed. Right? We think about this is measured in feet. This is measured in feet cubed. So the volume ratio is the cube of the similarity ratio. Right. So to wrap it all up, and this would be a good thing to write somewhere, we've got the similarity ratio, the surface area ratio, and the volume ratio. Well, let's just say that the similarity ratio is A over B. If the similarity ratio is A over B, then the surface area ratio is going to be A squared over B squared, and the volume ratio is going to be A cubed over B cubed. It's always good to remember that this would be feet squared, and this would be feet cubed. Always try to think about that with the units. So now that I've written this down, we should be able to say that, well, if I told you the surface area ratio for a shape is, I don't know, we'll say 25 over 49. Well, we could get the similarity ratio. We would take, well, the square root of 25 over the square root of 49 gives me 5 over 7. And as another example, if we were to say, well, 8 over, what would be a good, what's a perfect cube? 64? Ooh, that's not a good one. We'll just do 1/8. That's an easy one. we'll say 1 over 8 is the volume ratio. If you want the surface area ratio, first you'll need to go over here. And you'll say, well, the cubed root of 1, cubed root of 8, that's 1 over 2. And then you could say, well, the surface area ratio is going to be 1 squared over 2 squared, 1 over 4. There's not a good way to go straight from volume to surface area. You'll have to go to the similarity ratio first. All right, so this idea here will be useful on the worksheet. All right, that's all.